Hi everyone! Okay, so I'm in a little bit of a different location today to record your video. Unfortunately, this location is right in front of the couch, so Cam has easy access to block our view. Yay! So I apologize that he's going to be in the way. I will try to move him out of the way as much as possible, but we can learn some math today. Cam, we're learning about scale factor, perimeter, and area. Yay! Go away. Okay, so we're going to talk about scale factor. First, I'll review area and perimeter of shapes like our rectangle here. And we're going to talk about how scale factor can kind of affect the outcome of those things. You will need to use this stuff on the project that I've assigned you today. It's due May 1st, and you'll read more information about it there, but you're going to use some scale factor to calculate some measurements that I am going to require of you. You're also going to need to actually be measuring things. So you need a ruler or a yardstick or tape measure, anything that's got some measurements on it, you are going to need it for this project, okay? So maybe ask mom and dad if they have like a tape measure lying around or a yardstick. You can also use like any typical piece of paper will tell you like the dimensions of it, and you can kind of use that too. Like, oh, if a paper, like normal piece of paper is an 8 by 11.5, if you know that measurement is 8, you know, half of it is 4, half of that's 2, half of that's 1. So you can kind of make use of things like that too. So email me if you are having difficulties with that and I can help you out, okay? So anyways, we're gonna first start with finding the perimeter and area of the shape I have drawn here, and then we're gonna use some scale factor and calculate the new shape that's gonna be over here. So let's start with perimeter. The perimeter of this rectangle, well, I know it's a rectangle, and rectangles are helpful because that means that the width on one side is going to be the width on the other side. The length up top is going to be the same length down at the bottom. So I can figure out all 4 sides of that just by knowing that that's what rectangles are, and that will help me figure out the perimeter. If I know that the width on this side is 2, that means the width on the other side is also going to be 2. And if I know the length is 3 up top, I also know the length is going to be 3 down at the bottom. So the perimeter, thank you, Cam, the perimeter is going to be 2 plus 3 plus 2 plus 3. 2 plus 3 plus 2 plus 3. Okay, so 2 plus 3 plus 2 plus 3 is the same thing as saying 5 plus 5, and 5 plus 5 is 10. And it's just 10 inches. Inches is just one dimension because perimeter is just one dimension, so it's just inches, not inches squared or anything, just plain old inches because we're just measuring one dimension. Okay, now let's talk about area. Area, I know, is length times width, or base times height. And that means I'm going to take the 2 dimensions that I'm given here, and I'm going to multiply them together. So 2 times 3. The area is going to be 2 times 3, and I know 2 times 3 is 6 inches squared. So the area of this shape is 6 inches squared. Area is 2-dimensional because there's 2 dimensions. I'm multiplying together. Cool, now let's talk about scale factor. Scale factor is a number that I multiply a shape by to create a similar but different sized shape. So for example, I can multiply by any number greater than 0. We don't like dealing with negative numbers when it comes to measurement because there's no such thing as like negative distance, right? I don't have like negative 10 feet, like that doesn't make sense. So we're only talking positives. A number that is greater than 1, so a number for scale factor is greater than 1 means I'm multiplying by a number greater than 1. Well, if I multiply anything by a number greater than 1, I'm going to get a bigger number. I'm going to increase the size of the shape. But if I have a scale factor that is between 0 and 1, that's a fraction. And that means that that scale factor of a fraction is going to actually make a smaller shape, and I'm going to decrease the size of the shape. So for example, if I had a scale factor of 1/2, if I had a scale factor of 1/2, I would be making a shape that is half the size. So I'd be decreasing the size of the shape and to make it smaller. right? Because I'm taking half the size. If I had a scale factor of, let's say, 2, if I have a scale factor of 2, that means that I'm going to double the size of the shape. All of the dimensions are going to be twice as big, and I'm going to increase the size and make a bigger shape. For this example, I'm going to use a scale factor of 3. Okay, so my scale factor of 3. So sometimes when we write scale factor, we will abbreviate it SF for scale factor. So we're going to have an SF scale factor of 3. Okay, and what that scale factor of 3 does is that I'm going to multiply the dimensions of my shape by 3. That means all the dimensions of my previous shape is going to be 3 times bigger. And I know it's bigger because this number is greater than 1. Okay, so I'm going to show that by having a multiply by 3 here. And I'm going to now draw what my new shape is going to look like after I multiply it by 3. I'm going to have to use a ruler here. Okay, so let's start with the width. The width previously was 2 inches. So I'm going to take this dimension, this measurement of 2, and I'm going to multiply it by my scale factor of 3. So 2 times 3 is 6. So 6 is going to be now my new width, that measurement there, okay? So I'm going to find 6 on my ruler, okay? And I'm going to come over and I'm going to draw that. Sorry, you get to look at my back real quick. 6. Put my ruler down. Find 6. Go ahead and draw that shape, but I'm going to just label it 6 inches. Okay, so that's my new dimension. Now let's look at the other dimension of 3 inches. Okay, I'm calling that one my length. So 3 inches, and I need to multiply that by my scale factor of 3. So 3 inches times 3 is 9. So now my length is going to be 9 times bigger. So I'm going to find, not 9 times bigger, 3 times bigger, which means it's going to be 9. So I'm going to find 9 on my ruler here. And I'm going to go ahead and line it up. Again, sorry, you have to look at my back. Line it up here. Go ahead and draw my new line of 9. And I'm going to label it 9 inches. And while I'm here, I'm just going to go ahead and finish the shape. So we're going to have 6 inches going down this way. And I'm going to go ahead and do my 9 inches this way. Okay, there's my new rectangle. It's a 6 by 9 rectangle. Awesome. So now let's find the perimeter of area of this new shape, and let's see if the scale factor of 3 does anything to the perimeter and the area down here. Let's start with perimeter. So let's start with perimeter. Remember, perimeter is all of the sides added up. And I know with rectangles that whatever the width is on one side, it's going to be the same on the other, and same with the length on one side, it's going to be the same on the other, which means this is going to be 6 plus 9 plus 6 plus 9. So I'll go ahead and do that. 6 plus 9 plus 6 plus 9. Well, I know that 6 plus 9 is 15. And I know 6 plus 9 is 15, and 15 plus 15 is 30. So the perimeter is 30 inches. Remember, it's not squared. 30 inches. Oh, okay, so wait a second. The perimeter originally was 10 inches of my original shape. And after multiplying it by a scale factor of 3, my new perimeter is 30 inches. So what do you notice? If I have a scale factor of 3, it changes the dimensions by 3, but it also changes the perimeter by 3. So the scale factor is applied to not only the dimensions of the shape, but the perimeter of the shape as well. And that makes sense. The perimeter of the shape is made up by the dimensions. So that means that when I have a scale factor of 3, not only are the dimensions 3 times bigger, the perimeter will also be 3 times bigger. Okay? Now let's look at area. Area is going to be a little different. Okay? So area. No, I don't know why I made a capital R there. Area. Oh, sorry. Okay, so area we know is the 2 dimensions multiplied together. So 6 times 9. So 6 times 9. And that's going to be 54 inches squared. Area is squared. So the area initially was 6 inches squared. The new area is 54 inches squared. So my scale factor of 3, if I take 6 and I multiply by 3, I get 18. I don't get 54. So by having a scale factor of 3 does not change the area by a scale factor of 3. I wonder if you could figure out what it does change the area by. Okay, I'm not going to tell you right now, but I would like you to maybe figure it out. And if you do figure it out, email me. Let me know if you figure out what that relationship is. But I want you to take away from this video of a scale factor of 3. It will also change the perimeter by 3, but it does not change the area by 3. So having a scale factor only is going to affect the new dimensions and the perimeter. The area is going to be different, but not by the same factor. Okay, so that is one key difference I want you to notice. In your project, when you are taking a scale factor to create your new shape, you need to keep in mind that the perimeter will also be applied to that scale factor, but the area won't. So you will have to do that extra math to figure that part out. Okay. Now, sometimes you might incorporate encounter problems that will give you the 2 measurements and say, what is the scale factor? So you will have to look to see, well, what did I do to get from like this width to this width, or from this length to this length? In this project that I'm giving you, though, you get to pick the scale factor, so that won't be a problem. Okay. I hope you guys learned something from this video today. And if you have any questions, as always, you can always email me. I'm happy to help you guys out. Thank you so much for tuning in, and I hope to talk to you guys soon. Bye, guys.